All right, so we want to talk about constant velocity and how that affects your net force. So this is when net force is equal to 0 newtons. So we're going to analyze that. All right, so what do we mean by the net force is 0 newtons? Well, you have two scenarios. First scenario is the object is not moving. Now this can occur when you have an object where all the forces are canceling each other out. So here I have an object, and my object is sitting on a surface. It has a weight because it's on Earth, so all my objects have a weight, and from our last notes we know that weight is equal to mass times negative 9.8. It's on a surface, so we know that there is a normal force acting on it. It's not being pushed or pulled, it's just sitting there on the flat surface. So in this case, our normal force, or the magnitude of our normal force, is equal to the magnitude of our weight force. When I use the word magnitude, it just means a number or a value. So for example, we could say that the weight of this mass is, let's just say, 98 newtons. Negative 98 newtons, sorry. Okay, absolute value or magnitude would be just 98 newtons. The normal force would be 98 newtons, and the magnitude of the normal force would also be 98 newtons. So absolute value would be 98 newtons. So do you see how these two are equal in magnitude, equal in amount? When that occurs, your F net is equal to 0 newtons. So that's the first scenario. The second scenario is if I have a constant velocity. So if I have a constant velocity, what does that imply about acceleration? So for this, we're going to use our graphs that we learned first semester. So when you have a constant velocity, our position versus time graph is linear. Now, when we did our lab, it was curved. It was a power regression. So this kind of graph implies that we have a constant velocity. So our constant velocity looks like this. So the object is moving, but it is not what? It is not accelerating. So let's go back to what we were talking about. We're talking about this F net being 0. Well, in this case, remember F net, Newton's second law, is equal to mass times acceleration. if your acceleration is 0, then what is your F net? F net equals mass times, I'm going to put 0 in here, 0, and so this is equal to 0 newtons. An example of this would be something like a hockey puck on an ice rink that had just been zambonied. So if I have a hockey puck, here's my hockey puck. We're going to use this color. Here's my hockey puck. Okay. It was just hit, and now it is cruising along the ice. Okay, so these imply that the puck is moving this way. Okay, so it is in motion, but it is not accelerating. So we would say that the F net is 0. It is still moving, so things can be moving and not have a net force acting on them. So those are your two scenarios for a net force being 0. The first was if the object's not moving. That means that all of the forces are equal but opposite, and their magnitudes are equal, so they add up to 0. The other scenario is a constant velocity. Constant velocity, remember, implies there is no acceleration. If there is no acceleration, then your F net is 0. That's the case of a hockey puck on ice.